Hello everybody, getting ready to do Algebra 2 Math, Lesson 1.2 Part 2 today. And today we have a 26-point skill sheet today, and then we have a 5-point notebook guide today. And we're going to continue to graph quadratic functions today. We're using a quadratic model in Vertex form, civil engineering. Washington has two towers that each rise 307 feet above the roadway here. This is a bridge over some river in Washington, Tacoma, Washington. And then here is the model of the parabola here, of the cable stretch here between the two towers, can be modeled by this quadratic function here. What is the distance d between the two towers? So we have this distance here, we want to find out distance d here. So the vertex of the parabola is 1427, which would be right here. So what do we want to do about that? Well, the vertex of the parabola is 1427. So a cable's lowest point is 1400 feet from the left tower shown above, 1400 feet. Because the heights of the two towers are the same, the symmetry of the parabola implies the vertex is also 1400 feet from the right tower. So the distance between the two towers would be 2800 feet using that kind of logic there. So we're going to transfer this over into our guided practice now. Designs a bridge of cables that can be modeled by this, where x and y are measured in feet. Compare this graph to the graph of the function in example 2. Students, this is yours. Graph this function, label the vertex and the axes of symmetry here. We're going to do our guided practice now. So here's our function here. This was a function from the previous example here. So 307 feet, this is what that was here. We have 1 over 7,000. And then this is 1 over 6,500. So the difference here, I mean, here is this graphed here on a graphing calculator here. So what does that mean? The graphs of both functions open up, have the same vertex, axis symmetry. However, the a values of the functions differ. The graph of the function here is wider than this function graph here. We have a smaller number here, so it's flatter. The parabola will be flatter in this situation. That would be the difference here. Intercept form. If the graph of a quadratic function has at least one x-intercept, then the function can be represented in intercept form, which is like this, x minus p and x minus a. So students, in your own words, define intercept form. 5 points. Grade. And then we're going to get into a key concept here of intercept form of a quadratic. The characteristics of this graph here. Here is P0, then Q0. Those would be your x-intercepts here, how they relate to this form of the quadratic. And then x equals P plus Q over 2. So this would be your axis of symmetry here, and the way that you would find your axis of symmetry is it would be halfway between your two x-intercepts here. The graph opens up, and we know this if a is greater than 0 and down if a is less than 0. We know that. And the axis of symmetry is halfway between. That's why we use this situation here between P and Q. We know it's halfway between that. Again, we look at this graphic here. Here's your axis of symmetry here. So example 3, graph a quadratic function in intercept form. This is intercept form. So the x-intercepts are p equals -3 for here, and q equals 1. The x-intercepts occur at these points here, -3, 0, 1, 0. Find the coordinates of the vertex now. For knowing that, we can do exactly that. P plus Q, so we have x equals -1 will be the x-coordinate of the vertex. We plug that back in to find our y value, and it would be -8. So when x equals -1, y equals -8, that would be your vertex. This would be the graph of your vertex here, of this quadratic here. Here's your x-intercepts, here's your vertex here. Okay, so graph this function, label vertex, axis of symmetry, and the x-intercept is already intercept form. Same thing down here for you students. You are guided practice now. Here is our quadratic. Here are x-intercepts, p equals 3 and 7. So we put that and we find the average here, distance between 3 and 7, we get 5. So when x equals 5, that would be, we plug that back in, it'd be -4. So when x equals 5, y equals -4 would be our vertex there. So label the vertex, axis of symmetry, and then the x-intercepts. X-intercepts, vertex, axis of symmetry. Here is our graph here. Vertex would be 5, -4 here. And then y equals x minus 3, x minus 7 is our quadratic. So there are x-intercepts, and then here is our axis of symmetry. And that is 1.2 part 2 for Algebra 2. Part 3 is available here at this email. Thank you very much.